welcome. In this video, we're going to talk about systems of equations word problems. To start out, we're going to talk about how do you actually translate the question, come up with your variables, and then create the equation. Later on, we'll talk about how you actually solve those equations. So first, let's dive into the question and see if we can break it down. We're going to know that we're going to do a systems of equations word problem because it's going to talk about two different things in two different ways. Okay, so let's read this first question. A store receives a shipment of VCRs and CD players. A shipment of 5 VCRs and 4 CD players costs $1,950. A shipment of 3 VCRs and 6 CD players costs $2,250. Find the cost of a VCR and the cost of a CD player. Okay, so I told you before that we'll know we're doing a systems of equations because we'll talk about two things two different times. So we talked about VCRs and CD players, both of which are out of date now looking at the question because we don't really use VCRs anymore, and CD players are pretty much becoming obsolete as well. But for the sake of the question, let's go through and figure it out. So we talk about VCRs and CD players, then you see VCRs and CD players again, and VCRs and CD players again. So in the beginning, it tells you about VCRs and CD players, that's what we're going to be talking about here. But then you see it again two different times, and they talk about them two different ways. Okay? So since we have these two things, they become our variables. Okay? And so when you're coming up with variables, I know a lot of you like to use x's and y's all the time, but let's try to get away from that and make stuff that's more meaningful to the actual objects that we're talking about. So the first thing that keeps coming up is the VCRs. Okay? And so what we're going to talk about them is we need to know, okay, we're going to talk about something about a VCR. But what do we really want to know about the VCRs? Do we want to know how big they are, how many we have, how much they cost, whatever? And we can always find that in the last sentence. Okay? And it says find the cost of a VCR. That's the thing that we don't know. Okay? So it's really the cost or the money of the VCR. And then the other thing is the cost of a CD player. Okay? So we also need to know the money of the CD player. Alright? So you want to come up with variables that will represent VCR and CD player. So I'm going to use V and C as the variables that we're going to use. Okay? And then what you want to do is go through the word problem and change this to the letter V and the letter C. And then do that again here. And what you'll see is that the numbers will appear right next to them, and you'll be able to more easily create your equation. So if we look at the first thing they tell us about VCRs and CD players, it tells us that we have 5 VCRs and 4 CD players. So we have 4 CD players. And we're really going to add those together because you have 5 VCRs plus 4 CD players, and it cost, or it equaled, $1,950. Okay, and we get that from right here. Alright? In the second equation, or the second sentence, it says 3 VCRs, or 3V, and 6 CD players plus 6 CD players equaled $2,250. Okay? So while it may look complicated, it's got a word problem in there. If you'll take your time, figure out what the two objects are, define them using variables, and then go and replace those variables in the words, or substitute the variables for the words that you're actually using as variables, then you'll see that the equation should flow right out of it for most systems of equations word problems. Okay? So we're not actually going to solve this one, But you can look at it and see that the V's are lined up, the C's are lined up, the equals are lined up, and the numbers are lined up. So this would be more likely to be solved via elimination than substitution or graphing. Okay? Am I saying you couldn't do it those ways? No. I'm just saying it's easier to do it for this. Okay? So let's look at a different question and one that we can probably go ahead and start solving. Okay? So we look here and we've got Children's Department Store has bicycles and tricycles. Okay? They sell 50 total and they have 111 wheels. How many bicycles are there? Okay, so here we see two things and they kind of indirectly talk about them two times. It says that there are 50 total. So total means that there's, what are we talking about? We're talking about bicycles and tricycles. So it's kind of mentioned under the breath here about bicycles and tricycles. And there's 111 wheels. Okay, so this question doesn't give us as much straightforward information, so we'll have to go through and actually break down the question and think about what do we know about bicycles and tricycles. Okay, so but our two objects are bicycles and tricycles. Okay, so we have bicycles and tricycles. And what do we need to know about the bicycles and tricycles? We need to know how many are there. Okay? So we need to know the number of bicycles and the number of tricycles. Well, these should be pretty straightforward as to the letter I'm going to use. Okay? So now let's go to the information that they tell us about the bicycles and tricycles. It says that there are 50 total. Okay? You're going to see quite a few where they will use the word total. Well, what does total mean? It means you took everything you had and added it together. Well, what are the things that we have? We have bicycles and we have tricycles, and if we add them together, we'll get 50. So since we don't know how many bicycles there are, we use the letter B. We take the number of bicycles and add it to the number of tricycles, and it should equal 50. Okay? So that's where this first one comes from. So now we'll talk about the 111 wheels. So now this is going to come back to what do you know about bicycles and wheels and what do you know about tricycles and wheels? Okay? Well, everybody should know bi means two because a bicycle has two wheels. So there's two wheels on a bicycle. Okay? Plus we have some tricycles, and tri means three. So there's three wheels on a tricycle, or each bike has two wheels, and each tricycle has three wheels, and in all, or in total, there's 111. Okay? So this one wasn't as straightforward when it came to the setup, but if you actually think about what it's trying to say, you think about the word total, meaning you add up what all you have, and the wheels here, well, we know bicycles and tricycles have wheels, and we should know how many each one has. It doesn't have to be that complicated when you go to put them together. Okay? So now this one says solve. And this one could actually be solved either by substitution or it could be solved by elimination. Since elimination was the one that we last did and y'all have practiced it the most, we can solve it that way pretty easily. Okay? So with elimination, so when we go over here to solve, I'm going to bring my two equations down. And so, let me write that a little bit better. I've got b plus t equals 50, and 2b plus 3t equals 111. Okay? So when you're going to solve by elimination, you want to make sure that they're lined up. And we need to get the same number here or here as the one below it, and opposite signs. So since 2 is my smaller number, as compared to 3, I'm going to try to get this b to be a 2, but then I also want it to be a negative 2, since this one's a positive 2. So in order to do that, I would have to multiply this whole equation by negative 2. And so I'm going to do negative 2 times b and get negative 2b. Negative 2 times positive t, well that's a negative 2t, equals negative 2 times 50 is negative 100. Okay? And so make sure you don't forget to do this negative 2 times the 50. That's one of the most common mistakes people make is they forget to combine those or multiply those all the way across. Okay? So then you just double check, do we have the same number? Yes. Do we have opposite signs? Yes. Then that means we can eliminate this one because 2b's minus 2b's is 0b's, or there's 0. 3t's minus 2t's is 1t, or just t, equals, and 111 minus 100 is 11. So t equals 11. And then what does that really mean? Well, it means that the number of tricycles is 11. Okay, and see how if I used X and Y, it might not tell me exactly how much it is, but by using the letter T, you know exactly it's talking about tricycles, and there's 11 tricycles. Okay, but the question asks, how many bicycles are there? So this isn't our answer. We need to go back and plug in and see if we can find that. So we're going to go to one of our original equations, b plus t equals 50. And so b plus, and I'm going to plug in 11 equals, 50. And then b plus 11 in parentheses really means just b plus 11 equals 50. And then we can subtract 11, and b equals 39. Okay? And then you would normally want to go back and check behind yourself just to see. So we'll try this second equation. So if I have 2 times 39 plus 3 times 11, that should give me 111. Okay, so 2 times 39 is, well, 2 times 40 would be 80, and then we just take 2 off of that, so you get 78 plus 33, and that should equal 111. And then let's come over here, 78 and 33. That's 1, carry the 1, that's 10 plus 1 is 11. So we do get 111 equals 111, and so it checks. And so the number of bicycles right here, B, is 39. So you would say there are 39 bicycles is the appropriate way to answer this question. Okay? Let's take a look at another one. Okay? So now we have Anna has a pocket of dimes and quarters. She has 10 coins. There's a reference back to the dimes and quarters. How many coins are quarters? Okay? So we're talking about those two things. We can talk about there's 10 of them, and we can talk about their value. That's two references back to the dimes and quarters. Okay? So we have dimes and quarters. Okay? And we want to know how many. So that's the number of dimes and the number of quarters. Okay? It's important that you understand that it's talking about the number of them and not how much they cost. Okay? So I'm going to let D stand for dimes and Q stand for quarters. Okay? So now let's talk about the first time that they mention something about dimes and quarters. It says she has 10 coins. Okay? Well, what are coins made up of? They're made up of dimes and quarters. So if you took the number of dimes and added it to the number of quarters, that would equal 10 coins. Coins is another way to say dimes and quarters, nickels, whatever. Okay? So if you totaled them, you would get 10. So now we go to worth. Okay? So how much are they actually worth? Okay? Well, a dime is 10 cents or .10. So you could go .10 dimes plus the worth of a quarter. Well, we all know quarters are 25 cents, so that's 0.25. So we do 0.25 quarters. And when you had however many dimes you had plus however many quarters you had, it equaled $1.45. Okay? So now that we have this, we can go in and we can solve, and you'll notice that it is set up for elimination again. But we've got some decimals in here. That could make it a little harder, but not really. Try to think of the decimals just as normal stuff. You'll probably have a calculator for something like this anyway. So we could either do the dimes or we could do the quarters. It doesn't really matter. It's going to be easier to multiply by 0.10 than it is by 0.25, but it could go either way. So I'm going to go with the dimes here because 0.10 is smaller than 0.25. So that's where I'm going to go. Now we want to get 0.10 for this one, but we also want it to be a negative 0.10 because we want it to be opposites. So I'm going to multiply this equation by negative 0.10, and so I'll get negative 0.10d, and then a negative and a positive make a negative, and negative 0.10 times q is negative 0.10q equals, and then negative 0.10 times 10 is 1, and then a negative and a positive make a negative. Okay? So now 0.10 and negative 0.10 are opposites. Okay? And 0.10 divided by minus 0.10, not divided by, is 0. And then 0.25 minus 0.10 is 0.15 q, and it's a positive because 0.25 is bigger. And then 1.45 minus 1, or $1.45 minus a dollar, leaves us 45 cents. Okay? So now we'll go through and we'll divide by 0.15 to both sides. Okay? And then just try to think about this like 15 and 45. How many 15s are in a 45? There are 3. Okay? So this tells us we have 3 quarters. Okay? And so it says how many of her coins are quarters, and we say 3. Okay? Well, you could still go in and try to solve just so that we can check and make sure. So we know that D plus Q equals 10. So then D plus 3 equals 10. And so subtract 3, and the number of dimes equals 7. Okay? So now you could go back and plug into this, but that would be really hard. Think about this. If you have 3 quarters and 7 dimes, you should know how to do that in your head. 3 quarters equals 75 cents, right? Or 0.75. 7 dimes equals 70 cents, right? So then you do 0.75 plus 0.70, okay? And so I'll just put it under here. We'll do it like that. So you get 5 plus 0 is 5, and then you should get 14. Bring down your decimal. So it does check, and so we get there are 3 quarters. Okay? Alright, so now this will take us away from slide 25 and move us forward to slide 26. This is question number 1 from slide 26. This question will represent a lot of the questions that you'll see for systems of equations. Before, when I said it'll mention 2 things 2 times, this is a perfect example of where you'll see that. Okay? So you're selling tickets for admission to a school play, and you collect a total. So there's that word total again. Total means we're going to add our things up and get 104. And it says the admission prices are $6 for adults and $4 for children. Okay? You sold 21 tickets. Okay? How many adult tickets and how many children's tickets did you sell? So we see adult and children, two things, two times. We're talking about them about number of tickets and cost, or yeah, so the total cost or total receipt prices for the tickets. So you talk about it two different times. So we need to first define our variables. So I'm going to say A stands for, and it says how many, so this will be the number of adult. And then I'm going to say C, and again we're talking about how many, so this would be the number of children. Okay, so now it says we have a total of 104 dollars. So we're talking about the money. So we'll need the money here. So $6 for an adult ticket plus $4 for the children ticket equaled $104. Okay? So I said before, you probably want to go back when you see these, you put A and C in there. Okay? And then A, we want to know how many A's and how many C's. Okay? We go in there. Okay, and so you got $6 times the A, $4 times the C, and then which one of these has dollars in it? And it's 104, so that's why I used 104 here instead of 21. Okay, now it says we sold 21 tickets. Well, the different types of tickets are adult tickets and children's tickets. So if I took the number of adult tickets and added it to the number of children's tickets, it would equal 21 tickets, right? So now again, as you're seeing, that this could also be solved by elimination. But what I'm going to do this time, instead of solving it by elimination, I'm going to show you that you could have solved this one by substitution, just to give you a different take on it. Um, so in order to solve by substitution, you need to get it so that one variable is by itself. So I'm going to solve for A, and to do that, I need to subtract C from both sides. Okay? And so then I get A equals, and then the C's will cancel out, and you can just put 21 minus C. So A equals that. So then what I can do is I can take what A equals right here, and this A and this A are the same A. So I can take this and plug it in for the 6A right here, just for the A though. Okay? So I'm going to rewrite the equation, and then when I get to A, instead of writing A, I'm going to put parentheses 21 minus C. Okay? And then I'm going to keep going. Plus 4C equals 104. Okay? And now I'm just going to work it out. I'm going to go 6 times 21. Well, 6 times 1 is 6. 6 times 2 is 12. So you get 126. And then 6 times negative C is negative 6C. Okay? And then the plus 4C comes down equals 104. Okay? I have like terms right here. Negative 6C plus 4C is negative 2C. And then the 126 will come down, and the equals 104 will come down. Okay? So now I'm going to subtract 126 from both sides. I subtract it because it's a positive 126. I know this is a minus 2C here, but see how it's in green? That means it's negative 2C, or these are connected, whereas this is a positive 126, so I subtract, and I get 0, and then negative 2C will come down, equaling, and then 104 minus 126 is negative um, 22. Is that right? Yeah, negative 22. Okay, and then we're going to divide by negative 2, and C will equal a negative and a negative make a positive 11. Okay, so there were 11 children's tickets. Okay, so that equaled 11. And then what I'm going to do is I'm going to take that 11 and plug it back in to one of the equations. Now the easier one to plug it in for is the bottom one. So that's the one I'm going to plug it in for. So I've got A plus C equals 21. So A plus 11 equals 21. Subtract 11. And A will equal 10. Because 10 plus 11 equals 21. Okay? And so then you always want to try to go back and double check to see if you got the right answer. Um, so we can try plugging into this equation and seeing if it will provide us with the same answer. So if I do 6 times 10 plus 4 times 11, that should equal 104. Well, that's 60 plus 44. 60 plus 40 is 100, plus 4 is 104. So it checks. So then we know that that equals 10. So then if you answered this question, you would say something to the effect of there, or I guess you sold 10 adult and 11 children tickets. Okay? Now you could have easily solved this via elimination as well by just multiplying by negative 6 or a negative 4 to this bottom one. I'm not saying easy because some people don't see that as easy, but you can get it either way. Typically when it's set up in the form of elimination, you probably want to go that route because that'll be the shortest route. But I wanted to give you a little taste since I had done the previous ones via elimination. Okay? So the last question that we're going to do is question number 5 from slide 26. Okay, so rent a car um, rents cars for a fixed amount per day plus a fixed amount for each mile. 6 days, 550 miles, spent $337. Same car for 3 days, 350 miles, spent $185. What is the charge per day and the charge per mile? Okay, charge per day, charge per mile, that's what we're looking for. Notice how they talked about days twice, and then they talked about miles twice. Okay, two things, two times. Very easy to see that it's going to be a systems of equations. Okay, so we have D is going to tell us our charge per day, or the cost per day. And then M is going to tell me my charge or cost per mile. Okay, so that's going to be my D, and this is going to be my M. So I'm coming up here, this now becomes D's, these are M's, this is a D, and this is an M. And so now it should be really easy to create our equation because all our letters are right next to the numbers that need to be. So we have 6 days plus 550 miles equaled $337. 3 days plus 350 miles, I'll erase that so you can see a little bit better, equaled $185. Okay? So now, see how they're stacked again? So this would be elimination. So I'm going to actually do this one via elimination. Okay? So we need to look and see which one's going to be easier to turn into the same one with opposite signs. This is a pretty big number, probably not going to be as easy, and then we all should know that 3 will multiply to give us a 6, so we can just use that as 1. One thing that I would like to throw out to some of you high flyers out there is that you could turn a 6 into a 3 by dividing it by 2, which means you'd have to divide each of these by 2, which is possible, and you can probably do in your head. It would make the number smaller, but if it's not an even number like in this case, you're going to get a decimal. So just keep that in mind as you would try to do it. But if you like smaller numbers, that is a route you could go. However, for everybody else, we're going to try to turn this 3 into a 6, and then we want it to be a negative 6 because we need to have opposite signs. So to get a 3 to a 6, we'll multiply by 2, and then we'll make it negative so that it makes it negative 6. Okay? And so then I'm going to rewrite the top equation. And then let's go ahead and multiply this bottom one. So you get negative 6d, same number, opposite sign. And then we're going to get negative 700m equals, and then that's 360 plus 10, so that gives us negative 370. Okay? Draw my line. 6d's minus 6d's is 0d's. Okay? And then we'll have 550 minus 700. That's going to give us a negative. And then it's going to give us 150m. It's going to equal. Okay. So then we'll do 337 minus 370. And that's going to give me a negative as well. And that will give me 33. Okay. And then we'll divide by m. So you'll get negative 150 here, negative 150 there. And that gives me 1. And m will equal negative 33 divided by negative 150 is not one that I know off the top of my head, so I'm going to go ahead and pull up my calculator. Pull that over here to the side. And then negative 33 divided by negative 150. Okay, will equal. Notice how I didn't put the bigger number first. I put it as it was written. Make sure you do that. 0.22 is what I get as my number of mile, or my cost per mile. So now I'm going to utilize that and plug it back in to see if I can come up with my cost per day. Okay, so I'm just going to use the bottom equation because it has smaller numbers. So 3d plus 350 times 0.22 equals 185. Okay, so then let's go over here and do 350 times 0.22, and we get 77. So 3d plus 77 equals 185. I'm going to subtract 77. 3d equals, and then it would be 110, but it'll be 108, I believe. We'll double check because it's been a long night. 185 minus 77, 108, there we go. And then we're going to divide by 3 to both sides, and D will equal, that should give me 36, I believe. Yep, but you can double check. 108 divided by 3, 36. So there we go. The fixed amount per day is $36 per day at 22 cents per mile. Okay, and you can write that out. And you would want to double check that, but I'm pretty confident that those are the right answers. So thank you for watching the video, and good luck with the rest of your work.